In the last class, we have seen what are quadratic equations. Can you remember the standard form of a quadratic equation? Yes, ax square plus bx plus c equal to 0, where a not equal to 0, a, b, c are real numbers. Real numbers. This is the standard form of a quadratic equations. Now we are going to see how to solve or how we can find the solution of quadratic equations. Solutions. How many solutions are there for a quadratic equation? 2 solutions, because it is a second degree polynomial equation. For a linear polynomial, what are the zeros of linear polynomial? How many zeros are there for linear polynomials? We have seen in the second lesson. 1 minus b by a. Minus b by a. So the quadratic linear equation has how many solutions are there for a linear equation? One solution or a unique solution. So quadratic equations have 2 distinct solutions or 2 equal solutions. In certain cases there will be no solution. That we will learn later. Now let us see how to solve. There are different methods for solving or finding the solution of quadratic equations. One is method of factorization. Method of factorization. This depends on the method of factorization depends on the splitting the middle term of the quadratic polynomial. That is, you have we learned this last year in the 9th class. Factorization. See the example. For example, solve or find the solution of solve x square minus 5x plus 6 equal to 0. X square minus 5x plus 6 is a quadratic polynomial, and we know how to factorize this by splitting the middle term. Splitting the middle term. Minus 5. Product 6 into 1, 6. 2 factors 2 and 3. So minus 2 plus minus 3. So x square minus 5x plus 6 equal to 0 can be written as, what are the factors of this left hand side? X square minus 2x minus 3x plus 6 equal to 0, or 2 into 3 equal to 0 can be written as x into x minus 2 minus 3 into x minus 2 equal to 0. X minus 3 into x minus 2 equal to 0. That is, factors of x square minus 5x plus 6 equal to 0. X minus 3 into x minus 2 equal to 0. Now, we know the zero factor theorem. That is, if a into b equal to 0, if a into b equal to 0, we mean either a equal to 0 or b equal to 0 or both a equal to b equal to 0. These are the 3 conditions of zero factor theorem. That is, if a into b equal to 0, then either a equal to 0, then only we get 0 into b equal to 0. This will be true. Or b equal to 0, a does not 0. That is, a into 0 equal to 0. Or both a and b are zeros. A into 0 into 0, 0. We can apply this theorem here. According to this theorem, if x minus 3 into x minus 2 equal to 0, either x minus 3 equal to 0 or x minus 2 equal to 0. If x minus 3 equal to 0 or both are zeros, if x minus 3 equal to 0, x equal to 3. If x minus 2 equal to 0, x equal to 2. These are the 3 and 2 are the solutions of the quadratic equation x square minus 5x plus 6 equal to 0. X square minus 5x plus 6. What are the solutions? X equal to 3, x equal to 2. We have two solutions. Two solutions for this quadratic equation. So what is the first method of solving a quadratic equation? Factorization. Actually, we are using the splitting the middle term method for finding. Another example we can consider. Solve x square plus 2x plus 1 equal to 0. X square plus, what are the factors of this? X square plus product 1 into 1, 1, sum 2. So x square plus x plus 1 equal to 0. Then x into x plus 1, take this 2. Then plus x plus 1 equal to 0. Then x plus 1 again common factor. X here 1. X plus 1 is 1 into x plus 1. X plus 1 into x plus 1 equal to 0. That is by 0 factor theorem we can write x plus 1 equal to 0. X plus 1 equal to 0. X equal to minus 1. X equal to minus 1. Two repeated solutions. Same solution. But we can consider the solutions of x square plus 2x plus 1 are minus 1, minus 1. So here also splitting the middle term. Second method for solving quadratic equations is completing the square. Completing the square method. Completing the square. Very, very important method. Completing the square. See this example. Solve x square plus 2x equal to 3. X square plus, actually the equation is x square plus 2x minus 3 equal to 0. X square plus 2x minus 3 equal to 0. Consider this equation. This can be written in the form x square plus 2x equal to 3. Now, LHS x square plus 2x plus dash equal to 3 plus dash. That means when we add any number to this x square plus 2x, we have to add the same number to the RHS also. Then only we get this equation true. Now, which number is to be added to this? For that, let us compare this LHS with the first identity. LHS of the first identity. What is the RHS of the first identity? What is the RHS of first identity? X square plus 2xy plus y square is equal to x plus y the whole square. X plus y the whole square. We get this. X square plus 2x plus dash equal to 3 plus dash. To convert this into x square plus 2xy plus y square, if we can convert x square plus 2x plus dash into this form, then we can write the factors of this as x plus y the whole square. To find that number, we must first understand the property of this LHS. X square plus 2xy plus y square. First term is a perfect square. Here it is perfect square. Last term must also be a perfect square. Which square of which number is the last number? Must be the last number. We can get that number from the middle term. Middle term. What is the structure of middle term? 2 into x into y. 2 is there. 2. Here we have 2. Then x means root of x square. Right? Root of it, since first term is a perfect square, take its square root. Root of x square, x. Then y means another number y. We have to add the square of that number here. Then this changes into the form x square plus 2xy plus y square. So here we in the place of 2 into x into y, we have 2 into x. So how can we remain this as this same as 2x? We can put the third factor as 1. That is, this is 2x into 1. So in the place of y we have 1. That means add square of 1. 1 square. 1 square. Then this becomes x square, left hand side, x square plus 2x plus 1. 1 square means 1 is equal to 3 plus 1. What is x square plus 2x plus 1? As we have seen already, x plus 1 the whole square. X plus 1 the whole square equal to 4. Equal to 4. X plus 1 the whole square equal to 4. That is, x plus 1 the whole square. 4 can be written as plus or minus 2 the whole square. Now we got both left hand side and the right hand side squares. Square of the numbers. Here here what we have done, the expression x square plus 2x, by adding 1 we changed this expression into a perfect square. Perfect square. So here what we have done is, we have by adding 1 square or 1, we have completed the LHS as a perfect square. As a square. So that is why this method is called completing the square method. Completing the square. What we are doing here is, by adding 1, completing the square. At the same time, we change the right hand side also a square number. 4. By adding the same number. We are adding the same number on both sides. Then LHS becomes a square number, RHS also becomes a square number. Now, let us simplify this. X plus 1 the whole square equal to plus or minus 2 the whole square. Both are square numbers. Now remove the square. We get here x plus 1 is equal to plus or minus 2. X equal to 1 minus 1. Plus 1 transpose. Plus 1 becomes minus 1 by transposing. X plus 2 plus or minus 2 equal to minus 1 plus 2 minus 1 minus 2 equal to 2 minus 1 1 minus 1 and minus 3. Minus 1 and minus 3 are the solutions of x square plus 2x minus 3 equal to 0. Quadratic equation. By we have found out this solutions by completing LHS as a square. Simultaneously, RHS will also be a square number. This is the method. So since we are completing LHS, the method is called completing the square method. Another example. Solve x square plus 6x plus 5 equal to 12. By completing the square method. By completing the square method. x square plus 6x plus 5. Now LHS. X square, we can split this in the form x square plus 2xy plus y square. How can we write it? X square plus 2xy. 2 into 6, 2 into 3 into x, or 2 into x into 3. This is 6x. Plus 5. 2 x square plus 2 into x plus 5 equal to 12. This is not a perfect square, or we cannot write this as x plus y the whole square form, because here what should be to write to express this in the form x plus y the whole square, what should be the constant term? It should also be a perfect square. 5 is not a perfect square. But what should be in x square plus 2xy plus y square? What is the last term? To get this as x plus y the whole square, what should be the last term? Square of the factor, one of the factors of the middle term. This is square root. The square of the one of the factors of the middle term. What is x? Square of the first number. The square root of the first number, x. X square first number, so it's square root x. Since y is the third factor of the middle term, this should be the square of the third factor. Then only we can convert this into a perfect square in the form x plus y the whole square. So here 3 is the third factor, 2 already there, x square x, root of x square x, 2 is there. So x square plus 2xy plus y square, 2x 2. In the place of y we have 3. So y square, what is y square then? 3 square. 3 square means 9. But here we have only 5. So we have to change this number as 9. Then we get the LHS square. So when we change 5 as 9, to change 5 as 9, we have to add 4 to 5. At the same time, we have to add 4 to the RHS also. That is, we can convert this into a perfect square, or we can complete this as a square by writing like this or adding like this. 2 into x into 3 plus 5 plus 4, 9. 9 equal to 3 square. 3 square equal to 12 plus 4, same 4. When we add 4 to the LHS, we have to add 4 to the RHS also. 4 minus 4, 0. So this is x square plus 6x plus 9 equal to 16. That 9 means 3 square. So actually this form is x square plus 2 into x into 3 plus 3 square equal to 16 plus or minus 4 the whole square. Plus or minus 4 the whole square. Left hand side, x plus 3 the whole square equal to plus or minus 4 the whole square. X plus 3 the whole square equal to plus or minus 4 the whole square. Remove squares from both sides. We get x plus 3 equal to plus or minus 4. X equal to minus 3 plus or minus 4 equal to minus 3 plus 4 minus 3 minus 4 is equal to 4 minus 3 1 minus 7. 1 and minus 7 are the solutions of this quadratic equation. X square plus 6x plus 5 is equal to 12. Here we are finding the solution by completing the square. This part is not a perfect square. So let us see how we can convert this into a perfect square. Now read the textbook pages 74 to 76. After that, you do the examples 3 to 9. And then exercise 4.2 questions 1 to 6. Thank you.